Hi everyone, my name is Robert Davis and I'm the Group Chief Executive of EA Technology. I've got a few hats that are relevant to today's webinar. I'm honoured to be on the Energy Systems Catapult Board, which is looking at integrating all these different energy technologies into an optimised system. I also co-chair the commission in Cheshire and Warrington that's looking at sustainable, inclusive green growth, so bringing all of those elements together. I'm delighted to be part of this webinar today, and hopefully it's going to be a series of webinars that inform us all and engage us all in that process, that massive challenge of decarbonisation that we as an industry, as a society face over the next decade or two. And there's some massive challenges there, aren't there? So let's just go through some of those challenges, at least from my perspective, in broadly the order of size as I see them. The first is the generation, excuse me, of energy. Energy generation has changed a lot in this country over the last few years. And in the last 2 or 3 years, we've seen 50% of our generation coming from the renewable resources, so wind and solar, which is a fantastic turnaround from a couple of decades ago. That's a big step forward. But if we're going to achieve our 2050 targets, we've got to accelerate that. And energy generation needs to be almost entirely green, as it were, renewable within a decade or so. But that's a really big challenge. And it particularly brings challenges around flexibility, because as we all know, the sun doesn't always shine and the wind doesn't always blow. So that's my second challenge, really. How do we manage the flexibility that we need on the networks and in terms of storage and demand side uses for renewable energy, such that we have a balanced grid and we don't have to size the grid and the storage of energy in a way that's just unaffordable. That needs to be thought through. There's huge supply chains that need to be established to manage that load. The grid itself will need to be upgraded. But if we can find that perfect calm, as they call it, so we get all those demand side measures working effectively, then we can very quickly reduce the overall investment needed. It will still be billions, but we'll keep that to an optimized minimum. So the second challenge is around creating flexibility. The third challenge, as I see it, is heating. And a lot of our building heating at the moment is via gas, natural gas. That's all got to go. It's all got to be replaced. And there's lots of different competing technologies. The two, obviously, that most people will have heard of is around hydrogen on one side and heat pumps of one sort or another on the other. Whichever of those wins, and of course it won't be a single winner, it'll be a blend of those two different energy sources. The scale of replacement that we need to go through over the next 10 or 15 years is absolutely huge. And that's going to put massive demands on suppliers of that equipment, component suppliers to that equipment. And many of you will know about the component supply challenges in the electronics at the moment globally. So you're facing the scale of the challenge in terms of swapping out all of those heating systems in all of our homes and buildings and industries is going to be massive. The other one, which I think we're slightly further ahead on than heating, but not much further and still have a long way to go, is EV charging. And again, the number of people, I think something like 5 or 10% of new vehicles bought these days are electric vehicles, which is great. As an EV owner myself, the infrastructure publicly is still poor, and anything beyond the tank full, as it were, in terms of miles becomes really challenging, partly because there just aren't enough EV chargers, and secondly because many of those that are in position aren't working. So for somebody that needs to be able to get home with their car, this can represent a huge challenge. So beefing up that EV charging infrastructure is absolutely key. And there's a bunch of stuff around EV planning, engaging communities in that, car sharing, making EVs affordable for everybody. There's a load of planning and challenges that need to be faced there. I'm getting to the end now with the final two challenges that I see we're facing. One is more broadly around skills. And each of those areas that I've mentioned already, around flexibility, around heating, around charging of EVs, All of these require a supply chain of companies and people that will need training. And again, there's hundreds of thousands of people, if not millions of people, that need to change from their existing businesses to the new businesses that are going to arise in the ecosystem that we see emerging. So skills and training in that training ecosystem needs to be developed rapidly from my perspective. And finally, if we're going to deliver all of these things over the next few years, we're only going to be able to do that with public engagement. So we need to explain to people not only what they need to do to engage themselves in this process and this decarbonisation agenda. We need to tell them why, and why personally their actions, their purchasing choices, their behaviors and what they buy and how they consume and how they eat and how they travel and how they heat their homes and how they balance loads within their businesses, their energy loads within their businesses and their homes, is absolutely critical to us collectively achieving the objectives of decarbonisation. And I guess if you're listening to this webinar, you don't need any reasons or explanations of why we need to achieve decarbonisation. The flooding that's happening globally, the wildfires that are appearing all over the place, the Indian summers, perhaps I shouldn't complain, but the weather changes that we're seeing caused by climate change, even in this part of the world, are significant and are changing our society already. So in summary, lots of challenges to go at collectively through this seminar series. Hope you enjoy it. I'll be actively involved in attending them, and I hope you enjoy it too. Thank you.
That's great. Thank you, Robert. Okay, I've had some feedback that people can hear me now, so I will introduce myself again. I did do a little talk at the beginning, but unfortunately it seems that that's not worked out. So my name's Keith Everett. When I'm not making a terrible job of presenting webinars, my role at EA Technology is to support the DNOs. So I'm the depot sales manager, so I support with local training, instruments, and just sort of trying to get to know the guys down at a ground level on basis. So my background, I joined in EA Technology in December, and I think this is kind of relevant to talking about the overall series and some of the aims that we have with this, as Robert has introduced a lot of those as well. For myself, when we were producing this, I've got a background in working with the water utilities, and I know that we take a lot of it for granted in the developed world, that we flick a switch or we turn on a tap and these utilities just magically appear with very little thought as to what goes on behind that. So looking at net zero and wanting to talk about that, I was quite conscious that I feel there's a lot of news about net zero. A lot of the aims and objectives are quite rightly published, and as Robert has touched upon, there's a huge amount of information as to why we need to do this, but very little information about the impact on the networks and the network operators, the challenges that they face, how they affect us as the public, and what changes we need to make to these networks to make them more resilient, to modernize, and to put things like EV infrastructure in place. So through this webinar series, what we're aiming to achieve is to just talk about overall headlines and not get too technical with some of the detail. We want to invite people who do want to have those conversations to please contact us. You can visit our website at www.eatechnology.com or email us at sales@eatechnology.com. And what we'll look to do then is sort of get deeper into these conversations with people. The purpose of the webinar is ideally to just generate overall questions, provide some answers, become a conversational piece. And along the way, we're going to touch further into topics like new connections for electric vehicles, looking at network resilience and flexibility and visibility. So I'm sure a lot of the members or a lot of the people who've joined the webinar are related to the energy industry in some way. What we'd ask is please share this with any friends and family who may be working in sectors that could be affected or simply have a public interest in that. And again, everybody's welcome to contact us at EA Technology, and we'll look to try and further those conversations. So I'm going to hand over to Anna Duran, who's one of our senior consultants, who will just give us a bit of a reminder on the climate change and the UK response that's been put forward so far and where that's looking to go. and also Dave A. Roberts, our Commercial Director, who will talk about take a look at the traditional network and talk about some of the challenges that we may face as we move towards net zero.
Hello everyone, my name is Ana Duran. I am a senior consultant at EA Technology, and my role within EA Technology is to help our electricity network to adapt for the future. I've been asked to record this short webinar to give some background on climate change and why greater electrification of so many sectors of our energy use will be key to reducing our impact on the planet. It seems that every time we look at the news, social media or the internet, we hear about the impacts of climate change, which are already being felt around the world. Just a few items we've seen this year, for example. Record snowfalls in the southern states of the United States, flooding in Germany and Belgium, and more recently sustained high temperatures in southern Europe, followed by wildfires in Greece, Spain and France. So why is it important? Well, our activities all impact on the planet. Burning fossil fuels such as natural gas, coal and oil all release carbon dioxide and other gases that trap heat within the atmosphere. But beyond that, they are finite resources with multiple uses. If we burn them, what will be left for our future generations? COP26 will be held in Glasgow this autumn and will bring more focus to the topic. So what is COP26 and why is it important? It is the 2021 edition of the United Nations Climate Change Conference. COP stands for Conference of Parties, and parties are the nearly 200 countries who in 1994 signed the United Nations Framework Convention on Climate Change. In 2015, nearly every country around the world signed the Paris Agreement. The signatories promised to cut carbon emissions to limit global warming to below 2 degrees centigrade and ideally to 1.5 degrees centigrade above pre-industrial levels. So why 1.5 degrees? Well, at 2 degrees centigrade of global warming, scientists predict, and this is quoting the UN, a third of the world's population could be regularly exposed to severe heat. Almost all warm water coral reefs would be destroyed, and the Arctic sea ice would melt entirely at least one summer per decade, with obviously devastating impacts on the wildlife and communities they support. At 1.5 degrees centigrade, we can still expect global warming to have an impact, but less severe. To achieve this, COP26 has the ambition to secure global net zero by mid-century and keep 1.5 degrees centigrade within reach. Nearly 70% of the world's economy is now committed to reaching net zero emissions. Accounting for around half of the global economy, all the countries that make up the G7 have updated their 2030 targets to put them on a pathway to net zero by 2050. Here in the UK, we were the first major economy to put into law that we will reach net zero carbon emissions by 2050. And the UK announced the end of the sale of new petrol and diesel cars in the UK by 2030, replacing them with electric vehicles. This is putting the UK on course to be the fastest G7 country to decarbonise cars and vans. So why EVs? Why electrification? This chart shows UK carbon emissions by sector in 2019. 33% of the UK's carbon emissions were from the transport sector. This is even more than the energy sector. Despite vehicle engines being more efficient, there has been only a very minor reduction on emissions since 1990. Space and water heating are another major challenge, whether for our homes, this is actually the dominant energy use in the residential sector, or at business premises. The UK can't meet its net zero target without decarbonising these sectors, and electrification is one of the key methods to do this. So why electrification? After all, the sector is still made up a significant chunk of our carbon emissions in 2019. Well, hopefully this chart helps to answer that question. We are well on our way to decarbonising the electricity supply. According to National Grid, the system has decarbonised by 66% in the last 7 years. In 2020, there were 68 days when we didn't use any coal generation in Britain. Coal was only used to generate 1.6% of the electricity mix in 2020, compared to 25% 5 years previously. Christmas 2020 was the first ever coal-free Christmas Day, with zero carbon sources powering over half of our electricity demands. National Grid are aiming that they will be able to operate the system carbon-free by 2025. But of course, there will undoubtedly be challenges ahead. And as energy users, we will need to change our thinking about when and how we use energy. Maybe by taking measures like scheduling when we charge our EVs or charging how we heat our homes. As engineers, we will grapple with problems like, how do we balance a system with so much intermittent generation? How do we control so much distributed generation? How do we know what is being used and where? How can we support the connection of new technologies needed for electrification? And if we are using more electricity, how do we ensure we all have enough when we need it or we want it, using a transmission and distribution system that was specified many, many years ago? So these are the challenges that we at EA Technology are helping to overcome. In the next of this series of webinars, my colleague Dave Roberts will be discussing some of the challenges our electricity system may face and the potential solutions. I hope that you will join him.
Most electricity networks were built for a different time. Around the world, many grew to be based around a small number of large centralized power generators, where generation was created from steam, mainly fed from fossil fuels like oil, coal or gas, or sources like nuclear power. These provide electricity which is stepped up onto a national transmission system and then down through tapered distribution networks before reaching their destination to power our homes and our businesses. With much of the generation controllable and the demand predictable, the generators could be turned up or down to suit the needs of the electricity consumers, which was estimated pretty accurately in advance. The power would flow in one direction, which allowed the network to be optimized to suit. Now, one such example of this optimization can be thought of in our homes. Whilst the fuse coming into our houses might be good for 100 amps, around 30 kilowatts, a significant assumption has been in place for decades that you don't use all your appliances at the same time, and neither do you use them at the same time as your neighbours. Now, we don't contact each other to work out when the best time is to jump in the shower or turn in the oven, but the theory of large numbers shows us that our individual behaviours smooth out when we look over a wider group. So to your average electricity company, this smooth peak demand coming into a home is a lot less than the 30 kilowatts, actually closer to 2 kilowatts, which is around one hairdryer. And all of the upstream infrastructure has been sized to suit. Now, that's fine whilst the use of electricity remains relatively static, but those assumptions are starting to change, and quickly. The advent of new electricity generation from renewables such as wind and solar are now being seen right across the globe. And with these changes and the significant decarbonisation of that generation supply, it makes sense to use that electricity in other areas such as heating and transport. And this is causing two significant changes to take place. Number one, a fundamental change in the power flows on the grid, and number two, a need to use the power when the sun shines or the wind blows. So let's explore that a bit further. So in terms of power or demand changes, we know that the electricity and energy demand of one electric vehicle is roughly the same as a house over a year.
So to electrify all cars, which in many developed economies is pretty close to the number of homes, we're talking about a potential doubling of demand. But it's the pace of something that's really new. Let's go back to that grid infrastructure. These networks are huge and broadly old. Depending on which country you're watching this from, the bulk of your electricity network might have been installed in the 1980s, 70s, or even 60s. And there are some cables in large city centres around the world which have been in operation for close to 100 years. And all these things matter because the size of these assets means that the system can't be ripped up and started again in the short term. But for many countries to meet decarbonisation targets, we're expecting some radical shifts in this decade, the 2020s, as people move to electric vehicles and electrified heat. Ultimately, people can move faster than networks. And all this will start to put pressure on the system at a rate that's never been seen before. The second point we raised was around using power when it's cheapest. Now, it makes sense that energy should be cheapest when it's most abundant. So in our world of high renewable energy, it'll be the sunny and windy weather that should mean that electricity is cheaper. The electricity markets provide a feedback loop to reinforce this, encouraging us to charge our cars or heat our homes at certain times. This is a really elegant solution, which is likely to see us more of us responding to dynamic pricing, or indeed having systems to automate our ability to take advantage of this. But it needs to be coincident with when it makes best sense for the physical capabilities of the power networks. For example, what would happen if we all received the same signal and started charging our cars in the same street at the same time? So we can expect more sophisticated pricing, requiring an even greater degree of automation to keep the offer to you and me as consumers simple. So we can see we're now asking the electricity system to do a lot more and respond in a way that's sympathetic with the needs and the pace of society to support decarbonisation, which is now arguably the largest driver in all of this. We're going to explore what this means in detail over the course of this webinar series, with some subjects very close to our hearts, including the impact of accelerated asset ageing, the need for network modelling, the need for network monitoring, and the need for capacity signalling. These are just some of the areas we'll cover in some more detail.
Thank you, Dave. Yeah, as Dave quite rightly says, we will cover some of those topics as we go along. The intention with the webinar series is to sort of continue doing this periodically for some time. One of the aims that we will have for all of those episodes is also to invite guest speakers, third-party companies. So for this recording, we've been lucky enough to secure Guy Newey from the Catapult Energy Systems. Unfortunately, Guy was having some technical issues, so I think he has left. But again, any questions that anybody has, please do add them, and we will obviously make sure that we follow those up. Thank you.
Hi there, I'm Guy Newey. I am Director of Strategy at the Energy Systems Catapult, and I'm going to do a quick overview of this huge challenge that we're facing with the electrification of the energy system and the challenges in electricity decarbonisation in particular. It's a bit of a cliche in energy when you're discussing net zero and energy that oh yeah, we've basically done electricity. Great, we've made massive progress. Look how cheap offshore wind is. We're basically there. You know, let's stop worrying about electricity so much, and can we worry about difficult problems like transport decarbonisation or heating decarbonisation or industrial decarbonisation, or how we're going to get people to eat less meat. And it's a total cliche because the challenges that we're going to face over as we switch to a more electrified system over the next 10 years or so, 10, 15, 20 years, is going to be absolutely extraordinary. The best metaphor I've seen for it came from an engineer who said it's like redesigning and rebuilding an aircraft while the aircraft is still flying. and that sounds a pretty difficult and comprehensive challenge to face. Just a bit of introduction. So, as I said, I'm from the Energy Systems Catapult. For those of you unfamiliar with the Energy Systems Catapult, we're an innovation technology agency. Our job is to help the companies that are looking to take advantage of the transition to net zero. Our job is to help them grow. So to work with some of the brilliant innovative companies in digital energy technology and low carbon heating, in renewable power, crucially thinking about what this future system might look like. Previous to this, I worked in government as advisors to various secretaries of state, trying to fix some of these problems from the inside. So some of my take will be kind of tempered by how the politics of all of this works. So what's the size of the challenge? Well, the first characterization is we are likely to, and most of the scenarios that look out to 2050 see a much bigger role for electricity and electrification. So we're likely to see at least a doubling of the electricity system, perhaps a tripling of the electricity system over the next 20, 30 years. That's what the modeling would tell us, because of all the advantages of electricity and the success in getting some of the costs down, particularly on renewables. So we're going to go from whatever we are, around 330 terawatt hour system to something like 600, 700, and in some scenarios up to 900 terawatt hours. That's an extraordinary change of itself. We're going to need a hell of a lot of low carbon power. But that system is also going to be very different from the system we've kind of built up over the last 50 years, which has been dominated by very large, chunky power stations that are dispatchable, as we all know. We're going to move to, in fact, we're already moving to a much more renewable and intermittent renewable system. So we are on something like 35% of our electricity comes from renewable sources now, which a huge chunk is intermittent. And so, let you into one of the great secrets of the electricity system: the wind does not blow all the time, and the sun does not shine all the time. Certainly in Birmingham, where the Catapult is based, that is a fact we can't get away from. And so you've got to design a system which still has the reliability that we've all become used to, and is kind of bedrock of our kind of society, as well as switching to low carbon. So a very different type of system, which is also going to be much more decentralized. So yes, you're going to have some of the electricity connected the distribution level rather than the transmission level, and lots kind of smaller scale activity, whether that's solar panels on people's roofs, but crucially on the demand side. And this is where we're likely to see the biggest challenges over the next 10, 15 years or so. As people switch to electric vehicles, we're all seeing electric vehicle sales increase rapidly across Europe, but in the UK in particular. That's going to create more pressure on the electricity system if everyone comes home and plugs in at 5 o'clock in the afternoon. And that's nothing compared to if we switch to heat pumps, an even potential bigger draw on the grid, and obviously seasonally varied. So you're going to have a much many more actors and many more a greater increase in demand, and much more kind of variable demand, different demand pattern than we've got. Extraordinary change. And if that wasn't enough, you're also going to have this new opportunity and challenge of digitalization. The energy system is kind of in the foothills of digitalization. You're starting to see it in various different ways, whether that's much better information about what's going on locally. And I know EA Technology are absolutely the forefront of thinking about metering, getting feedback, and understanding what it means for faults on the distribution network and elsewhere. But it's also about much greater control for people in their homes, which is a really exciting change. But that landing of the digital system onto the analog system is going to be a really big challenge, and it's going to be as disruptive as digital technology has been in almost all the other areas of our life, whether that's how we watch TV and our kind of Netflix TV on demand change? Is there something similar going to happen in energy as it's transformed telecoms, etc.? It will be a very different system and will help, of course, with some of the challenges identified when we have a much more renewable heavy system. Can you make this system much more flexible, much more joined up? All of that's challenge. So that is the heart of this massive challenge that you're looking. What if we get this wrong? What could it be? Well, you're very much likely to get lots more spiky prices. So the energy costs will be very low when the wind is blowing or the sun is shining, even negative prices that we're seeing in the market at the moment. And if the wind is not blowing, then you're likely to see very high prices. We've seen this in the kind of late summer, early autumn. Not a lot of wind kicking around, demand starting to kick back in, and gas prices going very high. And at the moment, it's gas that's driving that cost. But if you look in future scenarios of how spiky that price will be through the day, depending on what's happening with renewables, that will be another fundamental change. So you've got a very spiky system. So that's a challenge for suppliers. It's a potential opportunity for aggregators and people who can provide flexibility to try and smooth out some of that demand, to get EVs charging at the time when it's low cost, to get people's heating coming on. Maybe it'll come on a bit early to avoid the peak pricing, but the consumer having the same experience. And the consumer is going to be absolutely central to this. Consumers are going to have to be able to accept this different energy system, and it's going to have to be made easy for it. So the companies that we work with who are trying to make that consumer offering work is really exciting. And if we don't get this flexible demand side to work in a way that works both for the system and for consumers, then we will get ourselves into difficulty. In many ways, what we had last summer from COVID, when you had a huge drop in demand, but still kind of more and more renewables on the system, was a kind of mini postcard from the future, and it ended up with grid or the system operator having to pay kind of one-off payments to big nuclear generators to be able to switch off. And I think one-off bilateral contracts between the system operator and large nuclear contracts to provide flexibility is about as far removed from this idea of the smart, flexible world that we all envisage as possible, because we haven't got the flexibility market signals in place for people actually to unlock. So that you could start you could have the system kind of creaking from that sense, and you could have and particularly at local level, where we're trying to understand, if suddenly everyone in an area gets an EV and they suddenly switch on and it's a constrained area, we're gonna have problems. How are we gonna make sure the system is operable, particularly at a local level? Challenges that we haven't had to think about for a long time in the electricity system, if at all. So what needs to happen? So I'm sure you're going to get into the discussion later on, and we're going to get a lot of questions on that. But for me, kind of some of the elements of this: fundamental market design, really thinking about what the future electricity market looks like. That we need to move from that system that's based around a few kind of dozen big power generators to one where there are hundreds of thousands, millions of actors operating in a smart way. Better locational signals, much more granular time signals on the system. I think that's absolutely fundamental, and BEIS and Ofgem have really got to grip that challenge. You need clear drivers for the level of investment in low carbon, whether that's nuclear or renewables or whatever technology it is. What's a real market driver for that demand? Particularly important as we get into the end of some of the renewable assets now we'll get to the end of their life. How are we going to replace them? Do they continue with subsidies? Do they get new subsidies? All those questions. Can we create a much kind of more market-based driver? Need to think about operability at the local level. We need to think about data, how that flows, how we get the right kind of data, how that's open where possible, where you unlock the value of that and get people solving some of these issues in the market rather than central government deciding it. And this other question, which is really fundamental strategic question, which is local versus national. You know, we've got a very nationally based electricity system. That's fine when you've got a few actors and a kind of relatively inflexible load. That is not suitable for the future we're going to, because it needs to think about the whole system. So if you're thinking about how you decarbonize Cheshire, as you know, some of the projects that Catapult and EA Tech have been working on together, you need to understand what's going on with the heat demand in a particular area. You need to understand the building stock, etc., so that you can get the electricity system ready for that, because you need to understand what the changing level of demand is. So huge challenges, huge opportunities, hugely exciting, huge risks. And I would, so absolutely right that we're looking at grappling with some of these issues as we go forward. Thanks.
That's fantastic. Thank you, Guy. So yes, as Guy says, there are a lot of challenges there, which I think are key to the future. So we're going to be looking into this in some detail in episode 2, where we'll start to talk about new connections, some of the challenges around transitions from where we are now to where we want to be. And further to that, we'll then start to look into things like network visibility, network flexibility. How do we make this information available to people so that everybody's able to tap into the resources that they need to make decisions for their business, for their network, and for themselves at home? So I hope you'll join us for these next episodes. Thank you for everybody's patience with the initial technical issues. We will be staying online for a few more minutes, so if anybody has any questions, please do drop those through and we'll answer those now before we sign off. Thank you.